Testing. Oh, okay. Hi, we made it. So technically I'm late by my own standards because I should have been here half an hour ago. That microphone is too much. I thought this headset would be fun, but it's too much. So yeah, the background noise, I just updated the background noise. Let's see how loud it is. I mean, feels alright, but should I make it lower? It's crickets, birds, and wind. I don't know if you can hear the birds. You can obviously hear the crickets. Yeah, just playing around with it. Some background noise. Maybe we can make it even lower. Okay, so that it's just background noise. Not late, I am. Maybe we planned this. Maybe we planned this to be at the same time. Yeah, no. I'd rather be late than not do a stream. So, yeah, I don't mind. But I also, like, I do mind making you feel like I don't care, because I do. But, yeah, I'm here. You can't see my mouse move because of the mic. I feel like, pilot? The helicopter pilots? Yeah, okay. Should we start? Before I start, I actually want to do a small recap of yesterday because, we left off in a 5, didn't we? Coming in loud and clear. Thank you. You might hear extra sound when I'm talking because I had to turn the AC on. Felt a bit hot. Normally I don't turn it on this early in the morning, but I did today. Roger. Okay, let's go. So yesterday I was doing this homework assignment, and I reached an error. Actually, even after I ended the stream for another half an hour, I just sat with it. I removed all of the useless code that I didn't need. Starting from this, which is the name of the chapter, I get the data, I load the data, I rename one of the column names, which has a funny name. Then I make condition be lower because it's not consistent. Filter by none because there are a lot of none conditions. Also filter by user found this comment helpful, useless condition. Then this is just looking, wait, no, help me. We are mapping the lowercase function that we did at the top. And then we are counting number of reviews because down here we filter by reviews that are less than, wait, help, what's happening? Over 30? We want reviews that are useful. And then we remove HTML code in the reviews. Then we, I change the condition to label review to text so that when I give it to the model, it knows what I'm talking about. These are the list of things we have. Then we tokenize. We have a tokenizer function coming from Bert and cased, actually. Cased? Huh, I thought it would be uncased. Anyway, apply the tokenization function, remove some columns that we don't need. Just looking at the columns that we have, then when I think the last thing is just train, isn't it? Like all of this is like useless code. Calling the model, doing some argument stuff. I think my main issue is telling it that I have 750 labels. I think it didn't like that. And then arguments, telling it I want epochs. Then loading metric of accuracy, because last time we loaded metric of, what did we load? I think last time we loaded a different metric. Here's our metric thing, and we have this trainer, and here I renamed these two to be my tokenized data sets training set and test set. I maybe eval should be eval, but I was like, you know what, let it be test set. But as you can see, it gave me an error when it came to the last line, trainer.train. Too many dimensions. And again, I think it's because I have 750 conditions. So should I filter by, like lessen it, make it less, or trace to, which is look at what people did to solve it. Maybe we can make it like less and then look at what people. Hold up. If I say, like just as if I say I have 7 labels, I don't, you know that, but that's just trick. Oh no, I have to run everything. The reason I remove the useless code is that even if I do a run all, I wouldn't get in trouble. So at least I did that for myself. So let us do that. Did I just run this useless side? Wow. I think there's an error here. I mean, I guess I still had to run this, but not whatever comes after. No, why did I do this? Why did I just make life harder for myself? So, there is this guy, who's already solved it. And there are 2 people actually. Marcus, I guess. And then Zakia. Cool names. They're using uncased. Why am I using cased? I don't care about the cases. C code available at. Ugh, so tempting. Give me a sec. While the code is running, do we have any errors? No, not on this side. So you go. You are here. Okay. Let's see if it works or not. It might not, and we are okay with that. The bird chirping is cute, right? Mapping. But is it too loud? Because if it's too loud, then it becomes annoying and not cute anymore. Mapping the lowercase thing. I could have said batched. It would probably be faster. I don't know why I didn't say batch equals true. It's always faster. Are you passing a string? I should be not passing strings because it's tokenized. Right, only numerical. Wouldn't tokenized be just numbers? I don't know. Should we check? Right where we should. I can add some lines of code for us to look at what we're sending it to. We have tokenized data set, and then right here I can say give me the first part. Save and please run. Yeah, but like to run. Okay. So I will, after being quiet because a motorcycle is passing, after I run this, I'm pretty sure I'm getting an error. So after that happens, I will, inshallah, look at the other person's code and see how that goes. Because I don't mind being spoiled, I guess. It's not a movie after I've tried it. But if I look at it without trying, then that's not how learning works, right? All right, let's go. I don't want to go back to the like learning thing, even though I should. This is documentation. Honestly, I will say, I use the documentation, transformers, and fine-tune a pre-trained model part quite a lot, especially for the metrics part, like at the end. So, yeah, I'm happy with, like, the documentation is chef's kiss, you know? It's amazing. It's beautiful. Like a string to integer. Maybe that's the issue. I just want it to run to see if I'm sending strings. Maybe we are. Maybe the labels are actual strings. So, yeah. I'm going to close this documentation. We're back at the NLP course. I don't need this BERT tab. Yeah. So, we would normally be at chapter 6. We already finished chapter 5. Wait. We didn't. What am I saying? We just finished this slide thing. We finished the slice and dice, and we're here. Why did it feel like we finished the whole chapter? If you go all the way down, this is what we're supposed to be doing. And then next is talking about big data. Okay. It felt like the end of a chapter, but it's not. Right? Okay. I'm going to click this, but not look at it. What happened? Save it failed? What the hell was that? Whoa. Save failed fine, but did we get error? Trainer. Oh, that's fine. That's a normal error. I forgot to put this from at the beginning. You know what? Don't worry, kiddo. Don't worry at all. Transformer, torch. There. My bad. I will run this. Well, I'm not mad at it, because do saves, okay. Oh, sorry, I was not paying attention to chat. Well, in torch, it would be an issue. Alright. Sure difference, really? Issue with saving? Just save the latest thing, I don't care. Quintana. Yeah, save my changes. Alright. Oh, why am I running this? I was supposed to run the one that's here. Campagetta. Where is it? I was supposed to run this here. There we go. And then Turning argument. And then let's see. Okay, that might be our issue. That I am dealing with strings when it wants tokenized things. Let's see. Going all back, all where are we? This here is running. I can put you at the top as well. Can I just call you like this at the top next time? Like this? Would that work? We can have this be up, and then hide this, and then close this. Alright, we're ready. Transformers, go. Still error? Ah! I always forget I have to restart. I don't like this at all. Is there a way for me to just comment everything that's inside here? I don't want to delete them. I just want to comment them. But I don't think that's possible. They don't take long, but like, why do I need to do a wget for something that I'm not even going to use? So I'm just going to do it manually. I know it's a bit annoying, so do forgive me for that. I just don't want to... I have to run the code again, and why should I add time where I shouldn't need to? Did you see torch version mismatch? Is there a torch version mismatch? Where? No. That wasn't the error. Are you talking about errors? The error is that after running the pip install, where? I mean, look, let me show you. It just says requires. And when I ran it, it's not a mismatch, it's just, it's not there. That's how I understand it, by the way. So I'm gonna go back here, comment this because we don't need them, we just ran them. Say restart. Where's restart? Restart session, yes. And then we say run all, and it should not be a problem. So now, oh, even the wget, is that necessary? Not really, no. It's already there. Let's see. Thank you for your patience, by the way. I'm gonna drink some coffee and see where that leads us. Yeah, let's see. Why is it taking so long to unzip? That's odd. Is this supposed? Oh, come on. I always just replace all. I always forget that there's a prompt asking me, and I'm like, why is it taking so long? Because I'm not answering the prompt. Eesh. Alright, let's, where are we? Loading tokenizer. Tokenizer loaded, locked and loaded. I should add a lot of military words into my vocab because I have this thing on. Isn't it weird and cute? Like, how big is this? Why is it so big? All right, let's go. Let's do this. Oh, my bad. Oh, that's fine. That's fine. I forgot to say where I'm. Train. Not rain. Oh, my brain is thinking rain. My brain likes rain. What do we think? We think If it's text, then it's muffled. Yes, it's text. Review is text. Why? Everything is text. How are you tokenized? The thing is, we're getting tokenizer from BERT. Is it our fault now? Like when I'm saying get tokenized, it does it. Tokenize function. Hold up, I'm only tokenizing text. I don't know what I want. But here's the thing, even we're not supposed to give it anything that's text. Do we just remove everything? So it has, my problem is that input ID is text, but how do I give it label? Do I update the word input ID to text? Do you know what I'm supposed to do? Because I don't. Yeah, you're right. It is, the issue was string related, and we are, oh wait, was it string or was it too many labels? Can I try and run everything again one more time and see if I get the same error? Because you know, there's this code saying if you try one thing too many times expecting different outcomes, that's the definition of insanity. Now I'm thinking I'm insane. Replace label categories into numerical. Can I ask how I should do that? Because I know when it comes to the tokenization part, let's go to some documentation and look at tokenization. Tokenizers, there we go. Tokenizer input sequence, let's try tokenizer. And do we model and then post, pre, padding, normalizer. Where's the data? Add token, decode, return. I know. Shouldn't there be an example? I want an example. Getting started. I hope you're not feeling frustrated because of me. Tokenization pipeline is, we say, you say tokenize this string for me, and it does, but I can't say tokenize the whole data set, can I? I really don't know that. Yes, I got the same error. Where is it? Yeah, too many dimensions of the string. Probably that. I can just do that? I can just say, make the string integer? That'd be weird. Oh. Torch tensor. Yeah, that one. Okay. So I'm gonna check for the first part in this person's code. And then maybe I'll understand what I'm supposed to do, because right now I really don't. Like, I understand the issue is with the string, and thank you for notifying me, but I don't know what I should do about it. So, how to write the code exactly, you know? So yeah, I'm sorry if you feel frustrated, like screaming at your phone or laptop saying, this is how you're supposed to do it. I'm sorry. Okay, so let's look at their code and see how it is from 2 months ago. So getting the libraries, logging into HuggingFace, which I didn't. Getting the data set, unzip, then loading the data set, then randomizing just to looking at the data set. Okay. What you may need to use the data set. Let's see. Rename the column, we've done that. Filter by none, we've done that. Lowercase. What is that? Filter unwanted string, meaning, see, I did the same thing. Users found blah blah blah. I literally did the same thing. We did that. And then compute review length, we did that. Filter, okay, they're filtering by a different number. Cool. Wait. Oh, you may need to use data set. Oh, that was wait, not what? Sorry. Do you wanna put something on Discord? Maybe the chat here is not allowing you to send pictures and stuff. Python from dataset import class label C2L class label. Huh? That turns string into integers. Okay. So you're giving me this line, which I will copy, paste somewhere around tokenization. It's just that I really don't know how to apply it. That's my issue. Where were we when we just looked at the data set? Here. Or here. Load. Paste. It's supposed to look like this. Class to label? Why is this here? Shouldn't it be? What's with all the equals? Are the equals supposed to mean... Oh, sorry. This is Python. From. Dataset, import, class to label. And then... Wait a second. This is how it's supposed to be. There we go. Probably have to download this. Call it this way. This part. And then we have the labels. Our labels are conditions. Our list of conditions. Oh, what did I do? First of all, this is from datasets, meaning we already have this. There should be an equal here. I removed it myself. Number of classes. We have 750 classes. But even if I call it that way, does that mean I have to update what's in the dataset? Label. For labels in label. What did I remove? Let me look at your code. From yeah. Sorry. I think I tried to fix some of these things. Yep, we have that line as well. The spam, ham, and ham. My labels are the conditions. I have that. I don't have a problem with the list of conditions. It should be, let's say, train. And then last line, I'm missing something. Oh, like this. This is what I'm missing for the last line. Class label string to integer, label for label and labels. Yeah, I think we're good now. Train and then condition. Condition without an S. Nope, it's just called text, not condition. So from here, if I just look at what am I doing? No, I just want to look at it. It should show me list of conditions. No, wrong one. Label. Wake up. There we go. Okay, so these are my conditions, right? Then, so these are my labels. Let me put the labels here. Oh, my labels. Labels are good. Now, for the names, I should do unique. I forgot how to do unique. Unique. Each time, I forget. Okay, so you just say dot unique and then the name of the thing. All right, let me go back to my code. Where were we? Where was I? Somewhere up here. Okay. So I should have dot unique, and then it tells me numbers. No. Let me go back to unique. Unique. Huh? This is how it works. It's the same. Oh, I'm using a different, oh, sorry. Missed chat as well. You did not have column named by anyone, etc. Just for example. Oh, that's the name of a column. Got it. I thought it just meant, I thought it was like, let me show you what I thought it meant. Class to label. I thought that's what it meant. Our current column is labels. And then for the text, don't know how it will work, but let's see. The unique one, we're supposed to put it like a method. So let's put our label as a method. Now we'll know. Whoa. Oh, okay, we're right. Unique labels. How many? Did we count them? I think it was the 700 thing. Len of you, unique labels. Yeah, it's the 700 thing. And if I don't say unique, if I just say labels, and if it's the same number, then we're in trouble. Let's see. It shouldn't be though. It should be like thousands and thousands. Oh. Yes, I know. I made a mistake. Thousands and thousands. 13. What? Whoa, 137. Yeah, that's a lot. So we have this and this ready. We know how many classes we have. Yeah, this name, I'm cool with it. Whatever. I think because I read it as class to label. So if I run this, it will just show me the output first. So let's just look at it first. Class label number do not match. Got one names versus. Huh? You're kidding me. You're kidding me. Fine, have your one. There's no one. Invalid string class labeled ADHD. Are you frustrated now that I don't know what I'm doing again? It's 750 different conditions. You're only calling one classification. Okay. I mean, the ham one you sent as an example, if I go back up the chat, the classes were 2 because of spam and ham, and I have 750 conditions. Why am I using this data set? Only God knows. But when I am calling it, it says that's not how much it should be. Got one name versus. I don't have one name. Look, like if I run this code up here, you stay. And we just call length of name. It should be 750, not 1. Why is it 1? Uh-oh. All right, we have an error. Look at us. What's the error? Shoot. Is the issue that I'm putting it inside this? Am I making it a double list? That's my issue? Yeah, that's my issue. Okay, len of view should be 700, whatever. Yay! We figured out the error. My bad. Alright. Yay! It worked! So we should say, I think this is not a good thing on my side, but I'm just gonna do that and see what happens. We should say, replace the labels, basically. But how would we know? No way, we can't do that. Can we do that? We'll have to say for each label, make sure you're replacing the right label. You can't just replace labels willy-nilly, you know? I guess if it's ordered, it shouldn't mess with the order. I don't know what I'm supposed to be doing. I appreciate your help with this. Even if I update the labels, what do I do with the text? Do I do the same thing? Is that, like, possible? I don't know. Do I update the labels or not? I don't know. Huh? Oh, there is no issue with the code. I should put it... No, there's no issue with the code. I'm just saying, if I update it, then I'll have to update the test set as well. This is for the train set. Isn't this like manual tokenization? Because like tokenization is supposed to do it for you. Did you do that? You can see it. This is the line. I just didn't run it. For label and labels. I ran it here somewhere to... Like, I actually did run it. This is the answer. But I didn't run it as in assigning it. Yeah. Still want to know how that guy did the tokenization and how close it is to our... Yeah, no worries. I still haven't run this part, the assignment part. I want to know, because like after the filtering and escaping... Oh, it's fine. I didn't do the 3 split thing. Drug train features. They're all string. What? Okay, you updated, you tokenized the review. I also tokenized the review. Then you mapped it. Did padding. I didn't do padding. Alright, I forgot that completely. And then remove things. Update the word condition to labels with an S. Really? Oh, I did label without an S. Are we removing... We can't be removing... Oh, you are removing review because, well, we have the input thing. Okay, what about the labels? What happens to the labels? Tokenized... Oh, wow, they're using a different thing. Sort frequencies and select only 50 most frequent labels. Is that what is happening? label count, sort, split, sorted labels. Change the string. It's, oh my god, look. Change string labels to integers for target feature. This is doing what you told me to do. That's good. We have our way of updating. Unique labels. Enumerate. That's what they're using. Map. Map, 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 map. We can put it in a map. Okay. I think I'm gonna try this one here. I mean, we have our way of enumeration. We're not gonna use theirs because it technically doesn't matter, but I didn't know how to apply it. Now I know how to apply it. We should do the mapping, which is we have we put into string to label. I should update the word label to labels, shouldn't I? Otherwise it would probably, yeah. So this is our string to label. Ours is called label without an S, and I think that's an issue on my side. And then we can do the mapping. Thank you, by the way, for helping me with this, because I didn't know how to apply it. Now I know, I guess. This is it. Where am I doing the renaming? Because I need to rename some columns again. Here. This is original data set. All right, I'll rename original data set labels. There you go. What? It doesn't even exist. It's called label. 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 Now should be labels. Merci, merci. And then I should change it back because when I run the code, it doesn't make sense to be called label. There you go. Thank you. Thank you. Thank you. So now your labels. Then I'm gonna. Our text is now tokenized, so it should be removed as well. We remove you. You know what? I'm gonna try tokenization again because I know I've already removed the columns. Now when I'm trying to remove them, it's like, it's not there anymore. And I'm, okay, fine, I'm sorry. Yeah. So now that is happening, I am hopeful about the future because I don't want to see everything about how this person solved it. I want to be able to solve it myself as well. Okay. So, while this is running, I'm gonna take a sip of the coffee. Don't run too fast. Oh wow, it's been like 45 minutes of me running around this code that, yeah, it's like half written, half copy pasted, half everywhere. All right, almost done. I am actually hopeful that it will work. So now we've removed you. We should be able to see we have labels. I think everything is now let's double check. Everything is now numbers. Train, and then wait, no, it's not. Obviously labels is not numbers, but just let's look. Okay, Have faith, have faith. We will update it right now. Pretty, so pretty. Labels, ADHD, you know. Input is the review. Patient ID is there. Don't know if we need it, but we have token type ID and what else? Let me go back and do we have attention? I'm not sure. Do we have it? Yeah, we have attention mask. So now this is the code we are running for labels. Bismillahirrahmanirrahim. Error. That's cool. We're cool. Our label. Yeah, you're right. It's an there's supposed to be an S. Labels with S. Go. Tokenized data set is not defined. You're kidding me. You're joking. Are you making fun of me? Yeah, I know. There's an S. Chat. What's happening? Why is tokenized dataset not defined? What does that even mean? Oh, there's an S. Haha. Mine doesn't have the S. Got it. List indices must be integers or slices, not string. I don't get it. The return value is not what it's expecting. There's an error, and I don't know what it is, but you know what? I'm gonna... My lambda is wrong? It's not even a lambda, but it's fine. Yeah, okay. I should make it a lambda, so that it accepts the thing. Okay, what do we call it? Do we instead of taking it from labels upstairs, we should say like yeah, basically. I should not even have this here. Like it's taking it from this. My lambda's wrong. Yes. For this in this. And this is supposed to be the return value? Label. For this, and this. The return value. So we have the labels, which is just an ID. Okay, so it's the integer. Like an int ID, something like that. Inted. You're supposed to be on the other side. Got it. The whole lambda is wrong. Wow, this must be frustrating to watch. For label, the integer ID and then label, and no longer in labels. Sorry. Return that. Yes? Does this make sense? We should probably not call this label, because it becomes, what do I call it? Return label? Is this frustrating to watch? I'm just trying to make it look similar. And then I don't need you like this, apparently. You should be like this because it's a lambda. Wrong? Do I just write the word lambda here? No. Forgot how to write lambda. Let's go back, because the girl forgot how to write lambda. Lambda. Oh, it wasn't here? Okay. Oh, isn't it double L? I forgot how to write the word lambda. Help. We are trying explicitly typecasting at index to an integer. Index. Typecasting. Indexes. How does the word lambda? Okay, the word lambda was wrong. There's a B. I forgot there's a B. Yeah, alright. Got it. But, wait. Not here. But definitely here. That I remember. There we go. Lambda argument expression. XXX. Lambda base height. I should write lambda. Should I not write lambda? Help me. We have return value, which is the U, and then I'm not even using what I'm supposed to be sending. What am I sending? Unique labels. Okay, I need my set, which is labels. For unique labels. That's it. I'm gonna run this and then let's look at the error. Okay, we have an error. Cannot unpack non-iterable integer object. Look. Unique labels. We have our set of unique labels. It's not unique. Got it. It's not unique. Alright, now this is unique, but I still don't think it will work. Same error. Now, like if I look at this guy's... Oh, what happened? There we go. We should just typecast, no? Should I? So we shouldn't use this class label? So, I'm sorry, but I will comment this part and try to use this one and see what's... Because, yeah, I think... thank you for your code, by the way, because it actually helped me understand what I'm supposed to do. But I'm gonna use this one. Okay. Oh. They're called labels. Not unique labels. Yeah. Okay. Is this typecasting, the enumerate, or is it like int, and then the thing? Because that would be typecasting. You say the name of the thing you want it to happen, and then explicit versus, yeah. Alright. Sorry for being very frustrating, but it's, yeah, part of the learning. Technically learning is frustrating, isn't it? We have an error. What is that? Why? Is it 2 words? Why is that an error? This is a condition name? I don't get it. Out of my 700 conditions, typecast the index to an integer. Index. The return thing? Shouldn't it be an... Isn't it an integer? Why wouldn't the index be an integer? when we ran it, it was integer. Hold up. If I run this part, oh, I can't run it on its own. I have to run the whole thing. Why not? We're here to learn. Let's try. This technically should just, without the lambda and everything, shouldn't it just work? Would this work? I have no idea. No. Cannot unpack. Huh. Good. Okay, that's good. So it's not taking... The integer is not there. So I should just use it myself? Hold up. Oh, this is wrong. This is not how it's supposed to be written. It's basically... I'm gonna go back up. So this is what we had last time. Can we take in index out of this? Do we say index and then I don't know. Where do we get index? For index. No. We just get the output. And the output is number itself, so it's fine. Type error occurs whenever you use string instead of indices or slices for list indexing. Yes. Yeah. Okay. So we have this. And if we try to lambda this, I don't know how to lambda this. Because like this is the output we want instead of the index thing. So we say u for u in. Yeah, we can just use this. Okay, let's lambda u. I'm just gonna replace u here and see if I can just use this. Z. No, same error. I'm getting a different type of error, by the way. It's the name of the condition that I can't deal with. I'm gonna have to do some control Zing here. Cause like you run okay. You just are fine. Just indexes. But I'm guessing I'm gonna copy you. And then see. Do I look at the list of conditions? Just the all 700 of them. Yeah. No. It's not a condition. Otherwise, wouldn't Control F catch it? Like if I... we'll actually have another case like that. Why would that be an error? Look, like, it's just indexes. Yeesh. Okay. To make this less frustrating, I'm just gonna run whatever is in this guy's code as a different cell, keep our cell, and see what the issue is. Okay. Just the S is not there. Each time I'm gonna... How many? Okay, it's been called in here as well. And here as well. Alright. There's no issue with the guy's code. Because... Why? I have my unique labels. And what? Now I don't know what's wrong with my code. I mean, you tried telling me, but I'm actually not really understanding. Because like the error I'm getting is not even a type error. I don't know. Like it can't send this because of this comma, maybe? But you had no issue, so yeah. Our code is wrong. So now that happened, should we be able to just run the rest? The model was already run. Let's look at our data set. Everything is now, yeah, everything is now numbers. You are already, it's still 750. I didn't make it smaller. You're not gonna be happy about this. And then, yeah, let's just, oh, you guys are already run. I need to run you again. And then last one. Bismillah ar-Rahman ar-Rahim. Huh? Too many dimensions? Something about the length at dimension 1? Should we do truncation? This is too much? Or is patient ID not supposed to be there? I don't know. I really don't know. Print each label with its corresponding integer. Okay, which are just indexes. Indices. And then you are checking for accuracy, precision, recall. All of that. I'm only checking for accuracy. Does it really matter? Okay. Training arguments. Epoch. Push to hub. No, thank you. If strategy epoch. Automodal. Yeah. Length of that. You know what? Let's also say that. Why not? I want to know how many they are. Based on... Whoa. No, don't scroll here. How many do we... Oh, sorry, forgot. Parentheses, yep. Sorry about that. Oh, wow, it's more. That's not good. I gave you a wrong number. But I should still get that error. That's weird. Why is it more? Hi. Hello. What's up? I don't know if it's similar. To our error. Oh, the key error. Technically we're past it, but to help me understand it, that would be useful. Because column comma separated. Delete commas in the first row. What is their error? Yeah, where is the error? Because you are... Huh? We're using the column as index before replacing the string. You aren't replacing the comma with anything. Oh, we're replacing the string but not the comma. Oh, that's good. So it doesn't recognize the comma. Thank you. Thank you. That helps. Yes. Now, what are you? You are our model. Where are we using you? Here again. Hoping for an error. We got it. Still something with the length. Expected 154 but got 133. Don't know what the error is, so I will continue trying to understand it from this guy's code. If we don't reach a solution, I really don't mind it. This really did help me understand stuff. I also had a nice win yesterday, so I don't feel so bad. Predictions, logits. Are we checking logits? Yes. Inside our compute metrics, we have NumPy. Well, that's easy. You have your validation. I use test. It's fine. What else did you apply to the data set? Print each of them. I don't wanna. I ran this part. Oh, I actually want to know what's inside. Did they remove patient ID? Yes, they did. Yes, they did. So patient ID is something that I have and I shouldn't. All right. That's the last thing I'm going to do. For the remove column thing. I'm going to remove patient ID all the way. All the way. Where? Where should we do that? I think just here is fine because I will remove it or just like add it to the code upstairs. Show me what you got. Did I say hi? Oh, I did not do padding. Uh-oh. Also, hi. I didn't say hi. The win was I ran a remove. Cool. Thank you. I didn't do the padding. Oh my god. You're right. The issue is the padding. It expects the, equal things, but it's not. Shame. Okay. You here. Alright, so should be after tokenization. It's fine. Let's go to our tokenized. This is the tokenization. So I'm just gonna add another line of code. That is the padding. And I'm just gonna steal the code from this guy. Yeah. Padding. Yeah. Yep. Let's just import our data collator with padding and then data collator with padding using our tokenizer. Is it called a tokenizer? It's called a tokenizer. And then we have data collator. And then what happens next? Do we add it somewhere? Where do we add it? Ah, here. Wait, am I calling it without it existing? Or am I just not calling it? Let's go all the way down. We're not calling it. Okay. That's it? Oh, sorry. Wrong button. Wrong button. Equals. Okay. I was able to run. I'm supposed to share the win. Oh my god. It actually looks like it might run. Thank you, Coffee, for helping us with the padding. I was able to run a blog, code from a blog that was about fine-tuning Wave to Vec, Facebook's thing. Like I updated the name of the dataset basically and some other stuff, and it ran and it worked and it was really cool, the output. So that made me really happy. This is going to take a while because I didn't even choose GPU. So yeah, it's running. That's all I care. Don't even care about the output. Okay, so things that we missed. That I missed, obviously, not you guys. Things that I missed was my input should never be text. So make sure that it's always numbers. And then I forgot to pad. Yeah, I think that was the two main things that I realized today. Oh, nice. Was it very different from what you had tried? Yeah, because the code was already written. I just updated things that I needed. So, yeah. Like, this is far more detailed. Like, the other one, huge code. Tried to read through it to understand what's happening. But, yeah, felt a bit different. Now, even though I'm supposed to go to the next lesson, I'm not. Not because we're late. We're not late, per se. Because I've been neglecting our lectures and focusing too much on HuggingFace, which that's fine. I'm learning through it. But we shouldn't neglect our lecture. So, yeah, let's start. Learning about transformers. Motorcycle passed, I think. Still, okay. Let's start learning about transformers theoretically. I think we sort of know about them practically. Start. Should I refresh? Because otherwise it's been a while since this was opened.
And then based on that...
Oh, no. Start from the beginning.
So this time I'm going to be talking about transformers, kind of the backbone of most implementations, not only in natural language processing, but also, a wide variety of other things as well. And I'm going to be talking both about transformers as they were originally conceived and implemented in 2017, and also some modifications that people make to transformers today to make them work much better in kind of modern language models such as Llama. So I'll talk about both of those at the same time, please.
Okay.
So as a quick reminder, I just want to review the attention from last time very quickly.
Yes, please.
And basically, if you remember attention, there were two varieties of attention. One was cross attention, where you attend to another sentence, basically, or another sequence. So you have one sequence that serves as your keys that you are attending to, and one sequence that serves as your queries, the things that you are using to attend to the sequence of keys. And so you can do that for, every element in the query vector.
Should I remove the background noise? Is it too loud compared to... Feels louder because...
attending to every element in the key vector. And the other alternative is self-attention, where you are attending to the same sequence. So basically you're guaranteed that the queries and the keys correspond to the same sequence. And so that's really the only difference between self-attention and cross-attention. Transformer-based models use either self-attention or they use self-attention and cross-attention. So I'll talk a little bit about two different types of transformer-based models that use both of those.
Okay.
And the way we calculated attention was basically by using the query vectors, taking all of the key vectors, and for each query key pair, we would calculate the weight between them like this. Then we would normalize it by using the softmax to make sure they all add up to 1 and are between 0 and 1. And then based on that, we took the value vectors and we multiplied in these attention weights, and we got a final vector for that. So a single query vector would result in a single value vector is the output.
Okay.
So that's just the review to get everybody's mind working a lot, everybody to come into the room. And so now I'd like to jump into the new content of talking about how transformers work. In transformers were proposed in the paper "Attention is All You Need" by Vaswani et al. In 2017. When this paper came out, it was kind of already clear to me that this was going to be a big thing, soon after the paper came out. And it actually has turned out to be a very big thing, of course. But basically, when it came out, it was a sequence model, a model that could generate sequences based entirely on attention. And so this is in contrast to what came before it, which is like they would have an RNN-based encoder, and then they would only use attention for cross attention. So um, all of the blocks in the encoder.
So attention was already there. I think 2015 we said. Through this paper, or was transformers already there and then attention? They were both there, just linked, something, or transformers is the 2017. Attention is 2015, right?
Up until this point, these would all be RNN-based blocks.
Mm-hmm.
And then they would have a decoder over here, maybe also consisting of RNNs.
Mm-hmm.
Actually, this could be a bidirectional.
Attention came before transformers, yeah.
And this could be a unidirectional RNN. And then they would only use attention for the cross attention part here. So this would be attention. And so what the transformer did is it basically said, we're going to remove the RNN as the sequence modeling, and we're going to replace this all with self-attention. So hence the name "Attention is All You Need." So they removed all of the other sequence modeling.
Unless you take the claim you guys were talking about last time in chat. Yeah. Sure, why not? Maybe it was even invented in the 1900s. I don't know. Because, like, I'm somewhat kidding, but also, a lot of things can be invented but not propagated. So, whatever was invented will just quietly die down because that person either did not share it with the world or it just didn't make a splash. Is that possible?
At the time the paper came out, it gave strong results on machine translation, and of course now it gives strong results on everything. Another really important thing is it's fast, and it only consists of matrix multiplications. And so this is really important for the same reason that I mentioned last class, which is that RNNs are kind of bottlenecked by the fact that you have to wait for the calculation from the previous state before you can calculate the next one.
Right. We said
Transformers,
that.
you don't have to do that. So it makes it much faster. And actually, I would argue that that's probably a bigger reason why they became very popular than like that transformers are a better modeling methodology or anything like that.
Would be hard to show a clear use case for transformers in the century before computers. Yes, I was joking, but also yes. I mean, we have a use case for transformers in the century, not a century, decade before deep learning. I'm talking about Transformers, the movie. Very bad joke.
Actually, mostly due to them being fast. So I'm going to go through two types of transformers, specifically encoder-decoder transformers. And these are used in models such as T5 and BART. And T5 is actually still reasonably
Up and running,
widely used
yeah.
in some applications. And also decoder-only models.
We have encoder-only models as well. Yeah.
And these are things like GPT and Llama, and this is used kind of most widely right now. Most of the new language models coming out are decoder-only models. So here are the architecture diagrams between them. And what you can see is a decoder-only model only has a single model here, where the encoder-decoder model has an encoder and a decoder, like this.
And
So
something is missing. This attention head of this part is missing because nothing is being fed here. It's just this and this. That's why it looks shorter.
the way the blocks of the way the transformer works is you have an input embedding, you have something called positional encodings, which I'll talk about a bit. Then you have multi-head attention blocks, and these multi-head attention blocks are followed by feed-forward blocks. So the multi-head attention blocks are basically doing attention. The feed-forward blocks are basically doing extraction of combination features to kind of mix together the different features from the calculated by the attention. And then in a decoder-only model, that's all you have. And then in an encoder-decoder model, you also have.
Hold up. Besides the softmax thing, it's literally the same as encoder, isn't it? Huh. I didn't notice that. I'm just noticing that. Like I said, this part is missing, but when you do that, it just becomes an encoder, but it's a decoder because of the softmax and the linear layers.
Something like this, where you have masked multi-head attention to calculate kind of.
No, sorry. It's masked because it's decoding. Still. Okay. Yeah. Multi-head attention, but masked.
In here. And then you have this multi-head attention here in place of the cross attention here. And then you also have the feed-forward network. And I'm going to go through each one of these in detail, but that's just kind of the general structure. And so I mentioned that like encoder-decoder models were widely used in T5. This was also the original transformer paper had this thing here, this architecture here. This is a little bit newer. So why would you pick one or the other? T5
different
and BART basically
different tasks, right? If you want the whole thing to be transformed, you use encoder decoder, sequence to sequence, like translation, summarization. I don't know, because when it comes to like ChatGPT stuff, they do summarization and they're decoder only. So
they picked this one kind of partly out of tradition, but also partly out of for things where you definitely have like a clear input-output structure, right? So it's like, I want to take in a summary, or I want to take in a document, that's my input, I want to generate a summary. Or I want to take in an English sentence, and I want to generate a Japanese sentence, and that's a translation. However, things get a little bit tricky when you're talking about something like a chatbot, right? So if you have a chatbot, what is your input and what's your output? Like, one thing that could be your input is like all of the context that you've seen before. And then your output could be, you know, the next like utterance or the next dialogue turn. But on the
I mean, the chatbot that can do translation, that can do summarization, are they one thing? Are they one model? Like, I have a hard time believing that.
On the other hand, another way you could look at it is, well, it's all just part of this one big sequence, and we want to model this whole big sequence at a time. And so because of that, decoder-only models basically don't force you to decide what your input and what your output is. You can just treat all of it as one long sequence.
Wow.
And that's a little bit more convenient. Another reason why decoder-only models are a little bit more convenient is they're simpler. So they just have, you know, these two layers, and they don't have like separate multi-head attention blocks for the encoder and the cross attention and the decoder attention here. And so because of this, because this is simpler and has fewer parameters overall, you can just make each layer bigger, or you can make more layers or other things like that. Actually, one thing I forgot to mention is this NX means you do this over and over again. So you have like multiple
epochs?
Layers of these blocks, basically. Cool. Any questions here?
Guys, wasn't this a really good explanation? Yeah. Like, it actually, I really liked it.
Yep. So what do you mean by same size is the first thing to ask about. Do you mean the same number of parameters, or do you mean each block is the same size? So for the same number of parameters, I think it really depends. There was a comparison in the T5 paper where they did something like that, and I think they did demonstrate that the encoder decoder was like slightly better, but I don't know if they exactly controlled for the size. I'd have to go back and look at that to tell you the details. But the T5 paper,
Wouldn't it technically be more resource, like this would be more resource intensive than this one? Just technicality, like this has more parts.
is actually a really, really nice paper in
I
terms of
think being less general lets you try and do more with smaller data and training runs. So while ChatGPT can do practically everything, it's huge. True. Yeah. Yeah.
how they
The other day I was learning about how much electricity a GPU needs. I was like, oh my god, that's too much. So yeah, just it being huge, take a lot of resources.
explore all the design dimensions and like training objectives and stuff like that. So you could take a look at that if you want to add more detail. Any other questions? Okay, so let's go into the details.
Oh, you mean the resource yeah, that's fair. Depends on layers. Yeah. I guess you can make this be twice as much as this one with more layers and hidden stuff. Yeah.
Details. So my goal of this by the end is that you have a very good grasp of
Transformers?
all of the basic components that go in here, and also some of the parts that Llama is changing from the original architecture, and why that's important. So that's kind of the main goal for today. Okay, so core transformer concepts.
Fine.
As I said, positional encodings are one core concept. Multi-headed attention is another core concept. Masked attention is a core concept, which I kind of talked about last time, but I'll talk in a little more detail. Residual layers and layer normalization, and feed-forward layers.
Cool. So. I can go now or I can go in 25 minutes. I think I'm gonna go in 25 minutes because I'm really enjoying this, but I'm gonna like see how much I can watch. Alright. Code example? Cool. Multi-heads. That's a lot. Still multi-heads. Something tells me I'm not gonna. Positional encoding is like, alright. That's technically 19 minutes, but something tells me I'm not gonna finish this in 19 minutes. Let's try. At least we try.
So inputs and embeddings are kind of boring, I guess, since we've already covered them. Inputs are generally split into subwords like this, like we talked about before. Embeddings, normally you just look them up, like we discussed in previous models. So transformer-based models don't really do anything fancy here. The only big thing, I guess, is that they really, when transformer models came out, they kind of like normalized the fact that you do subword segmentation in like every major transformer-based model.
Subwords, not words, not characters, subwords. Yeah, when something becomes boring, then you know, people get it.
Subword segmentation now. So skipping over that briefly, the next thing I want to talk about is multi-head attention, and this is kind of one of the big innovations in the transformer paper.
Okay.
So multi-head attention, the basic intuition behind it is that information from different parts of the sentence or sequence that you're modeling can be useful in different ways. And if you are just doing attention, with a single attention head, basically a single, attention vector, you might need to make hard decisions about which part of the sentence you pay attention to. So I wrote 4 examples of the word run here. Can anybody tell me how these are different?
Running a small business means managing. Running a mile in 10 minutes is pretty good, actually. That's pretty good. Because a mile is more than a kilometer. It's 1.6 kilometers. And it's healthy to run a kilometer in 10 minutes, so that's pretty healthy. Is not the subject. Subject is, this is actual running, human feet moving. Robber made a run for it, got away, and then Matsimak, stalking, had a run. I have no idea what that means. Something about Roaring Kitty doing a stream, probably.
How are 1 and 2 different from 3 and 4? Yeah, the first 2 are verbs, and the second 2 are nouns. Yeah.
Ah.
And so,
Okay.
how is 1 different from 2? If you know another language, if you translate them into another language, are they translated the same or differently? Yeah, the meanings are different. So this is all
is like a thin nylon fabric getting damaged. Huh? Really? Stalking. I read it as stock. Like money. Oh. Of course, I know what that means. I mean, I never saw it being used this way. But I know what that would mean. Okay. Let's put the subtitles up here.
It's called semantics, or it's called other lexical semantics or something like this. But basically the meanings are different. Like if you translate these 2 into probably many
Little garden pathy? Yeah. I mean, it's supposed to be the point, so. Do not apologize for a language that you did not invent.
other languages in the world, they'd have a different translation because they mean different things. Like physically, run a business versus physically run. And same for 3 and 4, right? Run in a stopping is very different than making the robber making a run for it. Now, if you look at the information, you might not even think about it, but if you look at the information you use to disambiguate these things, it's pretty different. Usually for syntactic things, you can just call from the nearby context. So, for example, if you have a noun to the left, usually that means something is going to be a verb. On the other hand, if you have a determiner,
that's part of speech tagging.
It's almost certain that that thing is going to be either a noun or an adjective. So you only really need to look at very local context to do this sort of disambiguation. But in order to disambiguate semantics, you need to look at farther context. One interesting thing is, like, let's say you want to learn embeddings of words. There's actually a trick that you can use when training word embeddings where you only look at the local context and you can learn syntactic embeddings, or you don't look at the local context and you only look at the farther away context and you can learn semantic embeddings. So, like, you can actually use this to get, like, influence your models in interesting ways. But anyway, that's kind of an aside. So the basic idea here, though, is different pieces of context can be useful for different purposes. And that's kind of what multi-head attention is trying to get at.
But how? I mean, it's cool. It's amazing. I just don't understand how. I understand what, but not how.
So it doesn't want to force you to decide whether to look at I or to look at business, but it wants you to allow you to look at both of them for different purposes. So how exactly does
No, not math. Just stuff. Okay, I think this part will help me understand, but not here. Okay.
How did attention work? I wrote the equation up here, and actually I should point out that the reference on the webpage for the annotated transformer is really nice.
Like that's that. Now I understand. Three-headed monster. It actually even made me think of the Harry Potter dog. Does it have a name? Fluffy. Fluffy. Yes. Like Fluffy. Okay. So yeah. That's easy to understand.
I got some of the equations directly from that, and you can look through and see PyTorch code for all of these things too, which can be helpful. So Anyway, we have the multi-headed attention, and it looks like this. I'm going to walk through the diagram that I have down here, though, because it might be a little bit easier to follow.
Yes.
So this diagram is a little bit different than what is presented in the attention is all you need paper, but I intentionally made the diagram closer to how you actually want to implement it in PyTorch, for example. So the first thing that you do is you have a whole bunch of query vectors and a whole bunch of key vectors. So the query vectors here, I only have 3 of them. The key vectors and value vectors, I have 4. That's kind of intentional. So this would be,
Why?
this is permissible. You must have the same number of key vectors and value vectors, but you can have a different number of query vectors if you want.
Value, key, but query. Okay. Just him saying it's permissible is sort of funny because it's like, oh, so this is halal. Okay, got it.
So is that clear?
Yeah, sort of. For now.
In which case, can you have a different number of query vectors and key vectors? Yeah. When it's masked, you could do that. Yeah, that is true. I was thinking something else. Yeah.
Hello, Keen. What's up? It's like so it's like a target word and a context word in embeddings, but multi-head attention allows you to take the context from anywhere in the query, since for every target word, yes, takes in all the other context. Yes, it is bidirectional and all that, right? No, it just it's like it sees the whole thing. Isn't that the idea? Or is multi-headed attention is part of the decoder, and decoder can see everything, but encoder can only see the past. That's what I remember. I hope I'm right. Let's see. Partly key means. Okay.
When you're decoding and you have a short sequence and you're attending to a longer sequence, yeah. That's basically it. You can have this when it's cross attention, because in cross attention, the sequence that you're attending to can be different than the sequence that you're using to attend. If you're doing self attention, these need to be the same length because the sequences are the same, so the length of the sequence will also be the same. So
Vector,
yeah, that's
query, and weights. I think more commonly seen kosher used than halal for something permissible in a non-religious sense. Isn't that for food though? Are we going into food territory? I'm just googling the word kosher because I've heard it used. Yeah, kosher food. Yeah, meh. Okay. All right. Non-religious, you say. You say. I say religious. Everything is based on religion. I'm sure vector, query, and weights are also based on religion somehow. Yeah. Yeah. Does Wikipedia say it's based on religion? Yes. Yeah. Okay. So, I mean, for saying like it'd be kosher to having different query. I prefer halal. Sorry, I'm overdoing it. You can say halal if you want. You don't have to say halal. For saying having different query and key. Yeah, let's go with permissible. It's alright, or just allowed, possible. No error given. Isn't halal also dietary? Nope. Not always. Wait, is it? Help me. Can I Google it? Would that be boring for you guys? No. Things can be lawful or permitted. Googling. Islamic religion. Is it food related? Mandatory, recommended, neutral, reprehensible, and forbidden. Ooh. Things. Halal is all encompassing. Look at Keen being so canon. You mean? Yes. Sorry, JSS. Our conversation just went out the window. Halal is all encompassing. All. Oh, comprising. Sorry. Yeah, that word too. Food, but also, what else? Something about animal welfare, compatible with other religions. Oh, as in being married into other religions, right? Yeah, that's also a thing. Kosher meat is permitted. Yeah, I know. Business. Oh yeah, you can do an halal business. Yeah. I'm gonna go back to Transformers. Hi. I love derailing. Halal is seen on food labels, yes, and I love them, especially when I see it on ramen. Hello. I actually like when people say hello to each other in chat. Makes me feel like we're part of a community. Yes. So does KNN, because I know KNN stands for K nearest neighbor, and the K is just like the number. And we were talking about context, right? Okay, I think in that sense that makes that, yeah. Okay.
So yeah, that's one thing. The reason why I made these different, just to demonstrate that they can be different.
Thank you.
So the first thing that you do is you multiply by weights,
Mm-hmm.
and you have 3 different weight matrices. The first, or actually you have 4 different weight matrices overall, but here we're going to use 3 of them. The first one is the query matrix. So you multiply this input by the query matrix. Then you have your key matrix. You multiply the input by the key weight matrix, and then you have the value matrix that you multiply by the weights here. And that's what
WWW. Alright, makes sense. Hello, YouTube people!
we
Yes.
have up here in the equation.
Even though it feels like there's a divide between the YouTube people and the Twitch people, it's not. We bring them together in chat.
Then the next thing that we do is we split and rearrange these into n attention inputs. And so the way we do this is we...
Oh no. I wanted to do a hand wave, but you can't see my hand. Oh well. I wanted to get in that hand waving action. And technically my hand is pink, so that works.
We split these up like this. So we have 1, 2, 3, 4. We split them up into 2 of them of size 2. So this is the case where you have 2 attention heads.
Huh.
And each attention head has a vector of size 2. In reality, usually your vector will be sized like 512 or 1024, and then you'll have 8 attention heads or something like this. Or much more if you have a larger model. But here I'm just doing a simple example.
So we're just splitting for no reason?
For illustrative purposes, and we do this over all of these. Note that this is like a little bit different than the equation that you have here. So the equation that you have here, you're splitting up first and then doing the matrix multiply. So you would be doing the matrix multiply of this matrix resulting in this, then you would do the matrix multiply resulting in this. But in reality, we do the big matrix multiply all at once just because it's more efficient to do it that way, because we want to do more big operations than do a bunch of operations separately. So this diagram here is closer to what you actually do in PyTorch.
So we want it to be split so that we can have the operations not be too much with the multiply? I'm going back, by the way.
So so you would be doing the matrix multiply of this matrix resulting in this, then you would do the matrix multiply resulting in this. But in reality, we do the big matrix multiply all at once just because it's more efficient to do it that way, because we want to do more big operations than do a bunch of operations separately. So this diagram here is closer to what you actually do.
That's exactly what I said, but in opposite.
In PyTorch, for example. So this is now a three-dimensional tensor. Like at this point here, you would have a three-dimensional tensor where we have 2 rows and 3 columns, and the third dimension is 2. So you can see it's kind of three-dimensional here. And that's also good because in the next step, we're going to run attention over each head. And when we run attention over each head, if we run attention over three-dimensional tensors once, that's a lot more efficient than writing a for loop and doing it individually over each of these split up things here. So that's
I don't get it.
That's the next thing we do.
Like it says we're running attention over these, and it's more resourceful to do them at once, not one by one. How? I'm gonna go back.
Attention over each head. If we run attention over three-dimensional tensors once, that's a lot more efficient than writing a for loop and doing it individually over each of these split up things here.
So are we treating these 3 as one thing? And it becomes one tensor of 3-dimensional GPUs, I think. Sure. Oh, throw GPUs at it.
So that's that's the next thing we do. And when we run attention, we basically calculate the attention vector using the query and the key. And then we multiply the value vectors by that attention vector, take the weighted sum by the attention vector. And that gives us a result that looks like this, basically. So, of course, the number of columns in this will be equal to the number of columns in the query vector here, because we calculate one representation for each thing in the query matrix. And then we concatenate them together. And when we concatenate them together, we get a bigger vector here.
Size being closer to this. It's more efficient because GPUs like to do the same operation in parallel over a lot of values. I see. Good.
And so when we do this, each one will get a different attention.
By the way, can you tell I'm holding the mic instead of it being on a table? Because it's normally on a table. Does it make a difference? Does it sound weird or better? Or do I care too much and I shouldn't? I don't know.
Weight, so we have a different attention weighting over all of them. This is what the code looks like. I basically put it up here, but you do linear projections for all of these. We reshape to get H heads. We apply attention to all of the heads.
Where's attention?
We concatenate them back all together, and then we apply a final linear layer. So we have a final matrix multiplication at the very end.
No need to hold it. Barely noticed. The reason why I'm holding it is when it's on the table, I'm sort of hunching over. Not really. Just like the style of sitting is chill when I hold it. Now I can sit, however. Yeah. But yeah, no, I'm just saying if it's not annoying, then sometimes I like to hold it, especially when I'm not typing, when I'm watching the lecture. But otherwise, it's easier when it's on the table and near the laptop.
And so I didn't really explicitly expand the attention vectors in the previous diagram, but I have them here. So this is an example from the Vaswani et al. Paper, and they're showing what happens when you calculate self-attention. And this is the self-attention values for the word making. And the self-attention values for the word making are mostly attending to like more more difficult.
Wow.
And that really closely matches with what I talked about before, right?
I think it maybe has more or less made for less background noise? I couldn't hear the motorcycle today. Motorcycles. I think no, it was on the table when I was coding. Now I'm holding it. I updated the noise suppression background thing. So maybe that was useful. Oh my god, that scared me. Why do I get so scared?
Doppler47 just followed. CL welcomes you.
Thank you, Doppler47. I love your name. I love the Doppler effect. Every time car passes me, when the window's down, it's like wee, and I'm like, Doppler effect. So yeah, thanks for the follow. Please, wait, if Doppler follows you, is it always the Doppler effect, or is the sound normal? Interesting. We have a lot of motorcycles passing us, so you'll be hearing a lot of it. Yes. The follow, the notification surprised me so much that I forgot where we are. Okay, we're here. Making more difficult. Got it.
More difficult. And that really closely matches with what I talked about before, right? So run in English is kind of a verb with lots of ambiguity. Like how you translate the verb, how you translate the word run would be very different based on, the other words in the sentence. Make is also a word with lots of ambiguity. So in order to understand how
we also see Doppler effect with like light being red and blue shifted from stars. I love that. Yes. How far the universe is expanding, or like how fast, sorry, not how far, is also Doppler effect. No. Yes. Yes. I think I remember watching Cosmos, the TV series, and yeah, like each time they're talking about it, they show, even the red shifting and the blue shifting, they show a person running and then they make it blue and red. It's fun.
you would translate it, you would need to pull in information from other parts of the sentence. And specifically, making something more difficult is different than like making a cake or making a house or something like that. And so because of that, it's pulling in lots of information from over here. But there are some attention heads that are like attending to the word itself. So this is pulling in information from the word itself. There's also another attention head that's pulling in a word from information from the previous word. So this could be one that's doing like syntax.
I like each time he's using the word attend for attention heads. Like, yep, that's the correct word.
Disambiguation of some variety. So you can see that each head is pulling in different varieties of information here, which is kind of the function of multi-head attention.
Cool.
So
questions from the audience. Does chat have any questions? We have
what happens if you have multi-head attention and the sentence is shorter than the number of heads? So that's a good question. It's actually not a problem at all, because here, let's look at the length of the sentence. The length of the sentence here would be 3. This
length of sentence being 3. I like you. That's a 3-worded sentence.
This number of columns is the length of the sentence. Here, the length of the sentence would.
I was never able to understand difference key query and value. I still don't understand it. I recommend you come and watch the lecture like on your own terms. But also now query is the thing. Let's see if we understand. I mean, yeah, we're getting there bit by bit. Thanks for the chat. And most of the time I compliment people's profile pictures. Should I compliment yours as well? I love the green.
Before, but we're not splitting on the columns, we're splitting on the rows. So you need to make sure that the rows are greater than the number of heads, and you always do that because you pick a representation size of something like 512.
We're splitting on rows, not columns.
To be equal to something like 8.
Okay.
So you you're sure that it's always divisible, it's always larger. There's actually something crazy called fine-grained attention that was proposed.
Fine-grained attention.
Where you made the number of heads equal to the number of representations, but people stopped doing this just because it's like
Too much?
it's overkill. You don't need that many
Ah.
attention heads. And actually, in the transformer paper, they experiment with different numbers of attention heads and found 8 was like sufficient for their
What?
purposes.
8 for what?
Attention in the original paper is not causal, right? So it can like get into future tokens as well.
Attention in the original attention paper from like 2014, where they first proposed attention.
Wasn't it 15?
In the original paper in 2014, where they first proposed attention, they were doing exclusively cross attention, like this. So they were attending.
Query key don't mean much. Could be wrong. Query is the input, is the prompt, whatever. The thing you send it to something happen. Right? But key and wouldn't vector be the wouldn't one of them be the representation? Because we just talked about word embeddings. So I don't know. We can
like
query key pair.
They everything with bidirectional RNNs, and then they were just attending to things in the input, not like doing causal attention. Causal attention was basically causal attention is like left to right or masked attention. There's like different ways of saying it, but masked attention was first proposed in the transformer paper, and it was
Cool.
It basically was only in the output also.
Did he recreate this in whatever PowerPoint is in Mac? Because he can select it. That's not normal. Or did he copy it as an SVG or something?
And then actually the first decoder only models, the first decoder only model was basically like GPT-1.
Yeah.
And there they did causal or masked attention just on the output side. Or just modeling sequences, yeah.
So in the input to the GPT, when we say that in the making example, when we sort of looked at the self-attention formation,
Self-attention?
Would making not be able to attend to future tokens that comes after?
That's a good question, and basically the answer is yes. So encoder, that is one argument for why encoder-decoder models might be more useful, because you can do bidirectional attention on the inputs.
Yep.
And there's also, so there's actually something right in the middle. It's not used super widely nowadays. But basically it's something called a prefix language model.
Prefix?
And a prefix language model is something where you only have the parameters of a decoder, but you allow it, during training, you allow it to do either masked or unmasked attention. So you only do masked attention when you're generating, but you also like do unmasked attention also. So it's just a way to train the model. It's a small modification to how you train the model, but some papers have said that's more effective, but I guess it's like more complicated, and I don't see it used super widely right now.
Okay.
Yeah.
Done? Are we done?
The multi-head attention. Yeah.
I think we have like 2 more minutes. Of questions? They're being quiet. Can I skip this somehow? Go forward.
The reason why we don't split on the rows, so if we go back to the reason why attention is so powerful in the first place, the reason why attention is so powerful in the first place is we're applying the exact same function no matter how long the length is. So that allows us to extrapolate essentially to like infinite, like as long as we want or short as we want sentences. if we were doing things like splitting on the length of the sentence, then we would run into the problem where we had the question about before, which is like, what if the number of attention heads is shorter than the sequence length? So you could come up with a model that did something like that. You could come up with a model that said, okay, I'm going to split the first quarter of the sentence and then the next quarter of the sentence and the next quarter of the sentence. And there actually were models like that back in the day, like where people encoded different like quartiles of the sentence separately, but it becomes a little bit tricky and like, what if it's shorter and stuff like that? So you need to deal with all these corner cases.
Yeah, you have to pad it. Hehe.
Cool.
Flashback.
Okay, any other things? These are all good questions. So.
Yeah, you have good students.
Okay, I'll move on to the next slide.
Yeah, we're done. Wow, half an hour. I am proud of myself. 29 minutes. That's quite a lot. Good work class / chat. I feel like calling chat class sometimes. GG. Definitely GG. What did we do today? What's your favorite part of today's stream? Thank you for being here. I really mean that. I know you don't have to be here. Today, it's still running, by the way, taking its sweet time. I can stop it, select GPU, run again. Probably that would benefit me. We looked at the code that I didn't really write yesterday and figured out our error was we were giving it string when it expects thank you. Oh my god, I'm not a professor yet. Ooh, that takes a lot. I would be assistant lecturer right now if I what will be on the test. You know what, I can't just give you everything so easily. I'm not that type of teacher. Study everything. I don't know. I actually don't know if Google Colab, I don't think so. Like, should we try? Because I'm gonna pause it anyways to use GPU. I'm gonna do this. See? No, it doesn't allow you. No, I don't think so. But we figured out the issue is we were giving a string when it expects not string integers, and also we forgot to pad it. Thanks for JSS helping me with the string integer thing, like probably being annoyed for the first half an hour of the stream. And then thanks for Coffee for telling us to do the padding when we forgot. And it's running. It probably isn't good, but it's running. I saw someone trying to explain it using DB operations, but I didn't get the reference there as well. By DB, do you mean normal databases? Or is that supposed to be something math and I don't understand? Thank you. Like I said last time, I feel like sometimes you guys are here and know things already and I don't, and I feel like it might be annoying for you. So if that's the case, I'm sorry, but I hope it's not. I hope it's like teaching your little sister how to learn something new. And then we looked at transformers. How cool is that? The coolest. 2 types, decoder only, and then sequence to sequence encoder. Oh yeah, databases, got it. Just in case it was something else. So if don't know if Doppler can hear us because there's an ad break I forgot to skip. Yeah, I think stuff is misleading. They connect those terms to that stuff, but I don't think it makes. I'm here, okay. It makes sense given the math. I could probably try to like Google it and understand it better. Let's see if by the end of this lecture we don't get it. We'll go far deeper into it, okay? So let's go to here and say, for those who are new here, I stream almost every day. Like technically every day, but sometimes I miss Tuesday, or just do a random stream. And inshallah, we'll be back here tomorrow learning the stuff that we were learning. Half of it is HuggingFace, half of it is this lecture. It's not always the lecture. because that would be just like us sitting doing nothing. Me, not you guys. Thank you and bye. Yeah. So if you'd like to stick around, sure. If not, you can go and watch the lectures yourself. That is probably more faster. But our class is pretty nice. We are nice to each other. I would not give my pen and pencils to anyone, but I'm nice. I don't trust people with my pen and pencil and other accessories. What is it called? Stationery. There we go. Yeah. So if you'd like to stay around either here, Discord, wherever, you can do that. Otherwise, see you next time. See me next time when we catch each other. That's it for today. It's been 2 hours and 10 minutes. I would only chew on oh my god. No. 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 Don't do that. I mean, if it's your pen, do whatever you want. Not mine. No. I mean, I wouldn't give it to you in the first place, honestly. I'm a bit stingy when it comes to that. And please see you. And like, even if it's an emergency thing, I'm like, okay, fine, I'll give it to you, but you better give it back. Because it's mine. Alright. Chill. I will chill. Thank you. And we are going to end the chat so that I don't keep you guys any longer than I should. Do let me know if you need anything. And I'm gonna end the chat in 5, 4, 3, 2, and 1.